All right, we're back. So now that we're all comfortable with elasticity, let's start to get into something a little more quantitative. So I'm very often going to show you functions like these, and you should be comfortable with calling out, for one, recognizing what you're looking at. So we have to ask, what are we looking at? Are we looking at a demand curve or an inverse demand curve? Remember, what is a demand curve? A demand curve is something which, if you give me a price, I will tell you the quantity demanded. So demand curve, the way we remember it is the name tells you what it's giving you. It's giving you the demand. So you say, well, what's the other half of that? Well, I give you price, you give me demand. I tell you how much it costs, you tell me how much you'll buy, how much you value it by. So well, it's not how much you value by it. It's given you how much you value. If I were to charge this much, how much of this would you be willing to buy? So so this right here that we're looking at, that is a demand curve. So an inverse demand curve is just going to be the flip of that. So an inverse demand curve like PQ is going to be, I'm going to give you a quantity and I'm going to ask you, how much do you value it? How much would you be willing to spend to buy this quantity? And so that's the flip. So it's kind of easier to think about what a demand curve is and then take the inverse. So just think to yourself, a demand function gives me demand out, so I have to put price into it. So whenever I see QP, it's giving me a quantity demanded out after I put a price into it. So that's a demand function. So that's what we have here, the demand function. If I were to flip this and you saw PQ here, then that would be an inverse demand. So I gave you a quantity, and so you can think of inverse demand is, well, what does inverse mean? Well, that means that I'm going to give you the thing that comes after the inverse. I'm going to give you the demand, and you're going to give me the other thing out, which in this case is price. So inverse demand is P of Q, demand is Q of P. All right, so now we can look at this and we can start asking some questions, so things that should be obvious when you stare at this thing. And so you'd say, well, let's say that the price was equal to 0. If the good was free, what quantity would be doing? How much would I be willing to take on of that good? Well, according to the function, if I set P is equal to 0, it just kills this part over here, and all I'm left with is 50. And so it's kind of an interesting thing. You'd say, well, it's free. So what does that mean, that I only take 50? Why don't I take 1,000,000? I mean, they're free, right? But you have to keep in mind that we have this assumption of diminishing marginal utility. So the more you get of these things, the less you care about them. So what we're effectively saying, when we say if the good was free, in a demand curve, the price is a surrogate for how much you value it. So when we say if the good was free, how much would be demanded, a different way of saying that same question was, how many of these do you need for you to value the next unit with 0 value? And so that's what 50 is. So that's really what we mean when we say, when the price is equal to 0, what's the quantity demanded? It's a little funny. It's actually what we're asking is, how many of these do you need for you to absolutely not care about the next one, for them to, the value to go totally to 0. Now, and we do these linear demand curves because they're easier to work with in these kind of simple examples. But real demand curves might not be these straight lines. They might kind of have an asymptote which sort of goes off to infinity. In which case, it really is the case that if the good was free, you would buy an infinite number of them. And again, what the interpretation of that is not that if the good was free, you buy an infinite amount, but it's more that there's always some value to the next good, even if it's a very, very tiny value. So if we had like an exponential or something that demand curve started high for and then went then that just means that for very low for a very, very, very high number of them that you own, you care about the next one not that much, but you still care enough, a little bit of enough, that you'd be willing to pay for one more so long as it was really, really cheap. So then we can start asking, how do we do this arithmetic to sort of do the exercise of saying, well, so if this is how many I would buy for this price, then how do I flip that around to ask for the inverse demand function, which is if I give you a certain quantity, I want to ask kind of how much you value that quantity, how much you'd be willing to spend for that quantity. And to do that, all you do is you take your demand function right here. So, if you look what I've done here, I've taken the P and I've replaced it with a P of Q, because I started out with a Q of P, and so it's just a notational thing. Like, this is a function Q and it takes P as an argument. Well, I now want a function P that takes Q as an argument. So I'm just replaced it with P of Q here. And now basically I just want to get this P of Q out on its own. So I'm going to then just move the 50 over. So that's what I did, move the 50 over. And then what do I want to do? Well, at this point, I am going to then take, what I've basically done is multiplied both sides by -1. You can imagine all sorts of other ways you could do this. If you prefer, you could say I took this and I moved it on this side of the equation, and then I took both of these and I moved them on this side of the equation, and that's why all of the signs flipped. So, so all of these are equivalent ways of saying the same thing. And so the last thing I need to do then is divide by my 0.5 here, and this now is my inverse demand function. So it is identical to this, but it's just written in a way where it's easier for me to see for a given quantity how much do I value that quantity, the inverse demand function. This is the thing that we actually normally plot when we plot these demand curves. We have quantity on the x-axis and how much we would pay or how much we value the item on the y-axis. So, okay. So now that we have this inverse demand, we can ask questions like, what is the choke price? So if I ask you what is the choke price and I have not given you an inverse demand function, then you should know that you need to figure out the inverse demand function, because you need the inverse demand function to figure out the choke price. So the alternative way of saying what is the choke price is asking, for what price does the quantity demanded equal 0? So this is that magical price where that captures the highest value. So like when you have none of these objects, then it quantifies how much you would value getting one of them. And if the price, the market price of that is higher than that value, then you would never buy one of these things and you would just stay out of the market. And that's why we call it the choke price. It kind of chokes off this consumer from entering the market. So this is the inverse demand function from the previous slide. And so what's the choke price? Well, I can just plug in a Q is equal to 0 here, and that'll kill this term, and my choke price is going to be just equal to 100. So $100 per unit, that is my choke price for this good. So if I want to plot both of those things, here I've got my inverse demand curve, which again, this is our standard way we plot demand curves. We've got the per unit price on the y-axis and the quantity demanded on the x-axis. And this curve here is actually the inverse demand curve that was being plotted. If we look at these things, the red number here, this is the choke price, which shows up down here. So it is the y-intercept of this curve. Now, we might also ask a similar question: at what quantity demanded is the marginal benefit of another unit 0? This is what I was talking about before, where because of our diminishing marginal utility, as we get more and more of these things, we care about the next one less and less. We value it less and less. And if our value of the next item goes all the way to 0, the price we'd be willing to pay for the next item goes all the way to 0, and that's equivalent to this curve going all the way to 0. So we can ask, at what quantity does this curve hit the x-axis? So in order to capture that, so this is me just sort of graphically saying what I just said. So the curve captures your marginal benefit. So this is the how much value, if I own this many, this is roughly the value of the next unit I could buy. So if I own more of these, then the value of the next unit I buy is even less. And so eventually I get down to the quantity for which the next unit I value not at all, and it is this term. So if I just plug a price in of 0 into my demand function, then the price, then the quantity demanded for a price 0 is equal to this quantity where the marginal benefit drops to 0. And that's just what we're saying here. Q0 is equal to 50, and so P50 is equal to 0. The value I have for the 51st unit, or the just greater than 50th unit, is equal to 0. So again, when you think of demand functions, think of what value that the odd things have for you. All right, so I want to go into consumer surplus, but I also want to make sure that everybody's got that so far. So let's pause right here, go back to Canvas, and take a look at some of the questions there.